Yes, my friends, I'm Professor Kumar and we are at Galaxy Tutorials. Okay, today we are seeing further exercise, the third exercise of similarity on page number 21 of the Maharashtra State textbook of the 10th standard, okay, Maths 2. And this is the fourth lecture on similarity. Okay, before going into the exercise, we have to learn about test of similarity of triangles. We have to recollect from our lower standards. My friends, there is a difference between congruent and similar. Two triangles are congruent if the angles are equal and the sides are equal. Okay, no exception. All the three angles are equal, all the three sides are equal. It is a congruent triangle. So it is like a Xerox carbon copy, exactly same. Two triangles are similar if now you can see they are not same size. Three angles are equal. This is similar. And the sides, the corresponding sides are in proportion. Same proportion. What does this mean? Do I have to recollect you from lower classes? You must have forgotten by now. Okay. All congruent triangles are similar. All similar triangles are not congruent. As you can see, the size, it can be double size, triple size, etc. So three angles are equal. Angles won't change. So 30-30, 60-60, 90-90, angles won't change. But there will be proportion to the sides. So I have AB, C, and I have P, Q, R. In this case, AB upon PQ, this side upon the corresponding side, ratio is equal to AC, corresponding side PR, is equal to BC upon corresponding side QR. This is what I will require for exercise 1.3 when I will prove that the triangles are similar. Please keep this in mind. And when are triangles for us proved to be similar? First is AAA test. All three angles of, I will put two triangles, are equal. With three corresponding. Okay, not all the three, not like that. So, how does this look like? I will show you. So in AAA test, I will have three angles, 1, 2, 3, and I have A, B, C. So 1 is equal to A, 2 is equal to B, 3 is equal to C. That is the meaning of AAA test. But my friends, sum of the angles of a triangle is 180 degrees. So if two angles are equal, automatically the third has to be equal. That is how we were finding the third angle in our lower classes. So here we get two corresponding angles of two triangles are equal. So in this case, if I prove like this, 1 is equal to A and 2 is equal to B, automatically 3 is equal to C. I do not have to prove that, and the triangles are similar. So this is AAA test, this is AA test. We use AA test. Now, because sum of three angle is 180 degrees, it is foolish to show the third angle because mathematically only it is like that. SAS test, angle between, let us put corresponding angle between the two corresponding sides containing it are congruent. So this is shown as, this is a triangle, this is side A, B, C, and I am talking of angle, for example, theta. And this is a second triangle, P, Q, R, and I am putting rho. So what does it say? Side. So if AB is congruent to PQ and angle B, which is contained in between, is congruent or equal to angle Q, and BC is congruent to QR, angle should be contained in the sides, then they are similar. Okay, be very careful. In this case, this is ABC, this is PQR, and I am told, for example, this and this is congruent, this and this is congruent, and this is congruent to this. This is not similar. The angle must be contained between the two sides, between the two arms of the corresponding congruent sides. Be careful. SSS test, my friend, is simple. All three sides are congruent. So this is but natural, it is a Xerox figure. 2 centimeter, 2 centimeter, 3 centimeter, 3 centimeter, 4 centimeter, 4 centimeter. So I will have similar, I will also have congruent. So this is how we are doing similarity. We are not doing congruency. Okay? So these are the tests, my friends, which we will use in our exercise 1.3 on page 21 of your textbook. Okay? Perfect? Okay. Before I go further, your textbook on page number 17 for more information from your lower class has provided the AAA test. Your book gives the AAA test. The proof of this is given in the textbook. Why am I stressing so much on it? First, it can be asked in the exam. Secondly, many sums in exercise 1.3 are based on the steps of the proof. How they do invertendo, how they do compoundendo. So we will just look at that theorem first before we go ahead. Okay, so others are not required because they have already SSS and all have been done in congruency chapters. This is very important because I require the steps also for the sum. Also the proof is given in the book. May come as activity, may come as write the theorem. Let us see. Remember the test. Don't create your own similarity tests. Tests are fixed. Don't make ASS an ass out of you. Okay? They are fixed. You cannot change. So, we will see the proof of AAA test given on page 17. This is page 17 of your textbook. What does it say? It says that in triangle ABC, and triangle PQR, what has happened? Angle A is congruent to angle P. Angle B is congruent to angle Q. And angle C is congruent to angle R. Okay, so we'll put this here. Given. Okay. How to prove that if three angles are same or congruent, the triangles are similar. In triangle ABC and triangle PQR, okay, angle A is congruent to angle P, You can put numbers if you like. Angle B is congruent to angle Q. Angle C is congruent to angle R. This is given. We have to prove. Triangle ABC is similar to triangle PQR. So one test of similarity we are proving. Okay. In this, okay, we are doing construction. And we are having M, N. Okay. We will not require construction on that side for the time being because the proof is simple. So we leave it like this. Now, proof. First, proof. Let triangle ABC be bigger than triangle PQR. We don't want to use SSS. All three sides are congruent. So it will be congruent and similar. We are not using. So we will make one triangle big, one triangle small, so that the sizes are different. Then, okay, first, second, mark points M and N on AB and AC such that AM is equal to PQ. This and this is same by our construction. And AN is equal to PR. AN is equal to PR. So basically I have a small triangle and I've extended it and made a big triangle. Or one part of my big triangle is congruent to the small triangle. Okay. Now, so third, we have to show that triangle AMN is congruent to triangle PQR. For that, we have to show MN is parallel to BC. Okay? Or we put it 4 so that you can remember the terms. Now, using BPT, I have MN is parallel to BC. Okay? Basic proportionality theorem. Corresponding sides are in proportion. Then, also MB upon AM is NC upon AN. Why? Because by BPT, I will have AM upon MB is, or we put it in proper shape, okay. AM upon MB is equal to AN upon NC, BPT. Okay, 1 upon 2 is equal to 3 upon 4. So if the lines are parallel, we know we have done earlier our theorem. Numbers are put. Do not put numbers in the exam. Okay, so this is there. Now we will invert this. Sixth, therefore, MB upon AM is equal to NC upon AN. My friends, you know this was called invertendo in the lower class. Inverse. Then we will add the denominator to both the terms. Okay, this is called, as you know my friends, componendo. Componendo, adding a numerator. So numerator upon denominator, okay, is equal to numerator upon denominator. So numerator plus denominator upon denominator is the second side also similar This is called comprehendo. And invertendo is n1 upon d1, numerator upon denominator, will become d1 upon n1 is equal to d2 upon n2. I'm just putting it because you must not be remembering your lower classes. Okay, these have all been done earlier. Now, between this, when I add, I will get 8 AB upon AM is equal to AC upon AN. Okay, between this, because AMB and and ANC. So when I add two pieces, I will get, so I add this and this, I'll get complete, and add this and this, I will get complete. Now, therefore, okay, when we check it out, therefore, AB upon PQ is equal to AC upon PR. Okay, this is how we have completed. Similarly, same way, we can show, we don't have to do it two times, we can show AB upon PQ is equal to BC upon QR also. Same way, by rotating the triangle. We can take other two sides also. So therefore we will get a conclusion. AB upon PQ is equal to BC upon QR is equal to AC upon PR. And because of three sides being in proportion, triangle ABC is similar to triangle PQR. So if the sides are in proportion, the triangle is similar. That is why I did this proof with you, and there are problems or sums in exercise 1.3 which require this comprehendo and all. That is why I put it up on the board. Okay, my friends. Now we will go to exercise 1.3 directly. Practice this 2-3 times. As I told you, those steps are very important. Also, the theorem is given in the book. Everything, solved examples and theorems of the book are important. At least 2 problems come from in the paper from solved examples. They believe that students should read the book because the book is important and it is made by the board. It is not a private book. So solved examples are very important. We are doing directly exercises because you can see the solved example. After you learn from exercises, it will become easier. Of course, we are doing reverse ulta, but it will be faster for you. Okay, because more sums come from the exercise and exercises are difficult for you. Let us look at exercise 1.3, okay, and go further on page 21. First sum in the book, figure given is, in the book figure is given A, B, C and DE, which don't look parallel, don't look 75 and 75. Okay, this is what is given in the diagram. In the figure, angle ABC is 75, angle EDC is 75. State which two triangles are similar and by which test. Also write the similarity of these two triangles by a proper 1-to-1 correspondence. This means that if you require to flip the diagram, you will have to flip it so that the sides you are talking about 1 and 1, 2 and 2, 3 and 3 are in order. Let us see the sum. So here I am supposed to say which two triangles are similar. Number 1, and I am supposed to give 1-to-1 correspondence, which is corresponding to which side or angle, etc. Let's see. In triangle ABC and triangle EDC, I am using this because it is given in the sum like this. Okay. Now, if for the correspondence, if I need to have the correspondence, ABC corresponds to EDC. Okay, I will need angle ABC is 75 degrees and angle EDC is 75 degrees. That is given. My friend, that is given in the diagram. Therefore, angle ABC is congruent to angle EDC. Given. If measures are equal, angles are congruent. Okay? Yeah. Angle ACB is congruent to angle ECD. Common angle. This is common to both the triangles. Okay? Therefore, triangle ABC is similar to triangle EDC. Which test we just saw? If two angles of two triangles are congruent, then those two triangles are similar. Okay, we have used the AA test. This is how to do the sum. We will move forward. Now you see, actually A was near 75, so we don't see, like we see measurements. You have to flip the triangle. So luckily for us, they have given us in B, and also it was lucky. Otherwise, if they are not written which triangle you take, you will have to decide. Because B and D are same, they will be in the center and the other two vertex will be on the side. In sum number 2 of the book, we are having two diagrams. Given to us two triangles. We are shown PQR 6, 10 and 8. And we are given another smaller one here drawn L, M, N. And we are told 3, 4, 5. Are the triangles similar? Are triangles similar? If yes, by which test? This is the question in the book. Okay. Now, in triangle PQR and triangle LMN, with my eyes only I can see that Q and M look like right angles, so they are better corresponding. I can't say Q is corresponding to N or Q is corresponding to L because the angle sizes are different. Okay, so PQ upon LM is equal to 6 upon 3. That is 2 upon 1. This is number 1. So I've taken this side, okay, and I've taken this side ratio. Then I will do the other side. QR upon MN is 8 upon 4. That is 2 upon 1. Then I've gone for QR and MN. Ratio is coming same. Then I will go for the third one. PR upon LN is equal to 10 upon 5. That is equal to 2 upon 1. My friends, you can see the third side also is in proportion. Okay, I'll bring all these three together. Therefore, PQ upon LM is equal to QR upon MN is equal to PR upon LN. That is all are 2:1. Okay, how I got this? From 1, 2 and 3. I brought all the three together. Now my friends, if the corresponding sides of a triangle are in proportion, then we have that triangles are similar. Therefore, triangle PQR is similar to triangle LMN, okay, by SSS, test of similarity of triangles. This is how to do the sum. Okay? Easy, not difficult. So, see, learn those three tests: AA test, SAS test, SSS test. Life will become very easy. Here angles are not given, here sides are given, so we have used the SSS test. Okay? We'll go to sum number 3. In sum number 3, they have again given us two triangles. So I have a triangle here, which is labeled as PQR, and I'm told 4 and 6. And I'm given another triangle, ABC, and I'm told X and 8. Okay, now how does the sum say? Two poles. So this is pole 1, this is pole 2. Two poles of height 8 meters and 4 meters are perpendicular to the ground. So they are perpendicular, nice of it. So both are straight. So you can see angle already one is same. If the length of the shadow of the small pole due to sunlight is 6 meters, shadow is falling, sun is here, shadow is falling, and shadow is 6 meters away. How long will the shadow of the bigger pole be? The bigger pole, shadow will be at B. So how much is BC? At the same time, when the sun is same on both, shadows will of course be in proportion. So this is how to find. Okay? So we will write first. So this is sum number 3. We will write our assumptions. An object and its shadow formed on the ground are perpendicular to each other. Okay? So they have given us the pole is straight and the ground can't be, ground has to be plane. Okay. Therefore, triangles formed by vertical poles and their shadows are similar to each other. Okay, this is the shadow 1, this is the shadow 2. So we are saying that these triangles are similar to each other. Okay, that we are not having crooked head or measurements are different, nothing like that. Okay, so therefore, triangle PQR is similar to triangle ABC. We are writing Q because order. Technically, we should have PRQ, right angle in between. But since this is not Pythagoras or something, so we will not use like that. Okay. Now, because triangles are similar, therefore corresponding sides are in same proportion. Okay. PR upon AC is equal to QR upon BC. Okay. So this is how we will get. And what reason do we write here? Corresponding sides of similar triangles. Do not write any short form in the exam. I keep reminding you. Use 2 lines if it does not fit. Now, we'll put the values. PR is 4. and AC is 8, QR is 6 and BC is X. Now my friends, X is equal to 6 into 8 divided by 4. You can see, and this will give me 12. Please write the answer in words, otherwise marks will go up. So they have asked, how long will be the shadow? The length of the shadow cast by the bigger pole at the same time is 12 meters. Do not forget unit. I remind you again, you don't write the unit, half mark will be deducted. So your hard-earned marks are important. Please see that they don't disappear by silly mistakes or when you overlook writing in the proper format. Let us see sum number 4. Sum number 4 of the textbook. It says, there's a diagram. A, B, C and Q and P. So this is the diagram given. In triangle ABC, okay, AP is perpendicular to BC and BQ is perpendicular to AC. And P lies between B and C and Q lies between A and C. Then prove that triangle CPA, this triangle is similar to triangle CQB. This is similar to triangle CQB. And given the measurements, AP is 7. So I have AP is 7. BQ is 8. BQ is 8. BC is 12. BC is 12. I am supposed to find AC. How much is AC? After that, second step. First I must prove these two triangles similar. Then I must find the measurement of AC, that is X. Let us start. Then, in triangle CPA and triangle CQB, getting the right angles in the middle. Be careful. Okay. In these two triangles, angle CPA is equal to angle CQB and 90 degrees. Okay. Number 1. This is given. Then, okay. Therefore, angle ACP is equal to angle BCQ, common angle. Okay, therefore, triangle CPA is similar to triangle CQB. How? A test of similarity of triangle. Now, this is the first part we have done. Second part. AP upon BQ is equal to AC upon BC. Reason, corresponding sides of similar triangles are in proportion. CSST, right? Full form. Okay. Now putting the values, 7 upon 8 is equal to AC upon 12, where AC is x, you can also use x. Therefore, x is 7 into 12 upon 8. Then this will give you 10.5 units. Please write the answer in the words. AC is equal to 10.5 units. This is how to do the sum. Okay, my friends? Very, very simple sums. We will move to sum number 5. Please practice. Separate the triangles like how I do. You will even change the direction and draw them in the same direction if you still find it difficult. But get used to it, because these are the sums which come in the exam. Sum number 5. Diagram given. Okay, and these are joined. And these are labeled P, Q, R, and S, and the intersection point is A. In trapezium PQRS, side PQ is parallel to SR. These are parallel, my friends. AR is 5 times AP and AS is 5 times AQ. Okay, so first PQRS is trapezium. Given. Second, we are having PQ is parallel to SR. Third, we are given that AR is 5AP, or in simple language, AR upon AP is 5 upon 1. Okay, and we are told AS is equal to 5 times AQ. Therefore, AS upon AQ is 5 upon 1. We will need for similarity things like this. So learn to convert so that it becomes easy. We have to prove that. To prove that, we have to prove that SR is 5 times PQ, or SR upon PQ is 5 upon 1. We have to prove this, my friends. Okay, so we'll start. In trapezium, PQRS, side PQ is parallel to side SR given. Then transversal SQ intersects them. So these two lines are parallel and this intersects them. So this is how we are showing S and P. Okay, this part of the triangle I am showing. Then, therefore, angle PQS is congruent to angle RSQ. Okay, why we are saying so? Alternate angles. And fourth, angle, therefore, angle PQA is congruent to angle RSA. Okay, so first we had the full, I've just made it till A, same angle. We are talking of the same angle here and here. Okay, why? Because of betweenness, we put 1. Because of betweenness, SAQ and RAP or PAR. Betweenness has to be shown. That is why I can take smaller part of that angle. Okay. Now, fifth, angle PAQ is congruent to angle RAS. Okay. This is vertically opposite angles. This and this is vertically opposite. Angles in an X are vertically opposite angles. Then, therefore, triangle PAQ is congruent to triangle RAS. I have a test of similarity of triangles. I proved all the angles to be. So a test, which is a test in brief. Seventh, therefore, AR upon AP is equal to AS upon AQ is equal to SR upon PQ. This is number 2. This is corresponding sides of similar triangles. Okay. Now we are given measurements. Therefore, 8th, AR upon AP is 5 upon 1. Therefore, SR upon PQ. Okay, because we are getting this from given AR upon AP is 5 upon 1 and AS upon AQ is 5 upon 1 given. See, my friends? But this is not they asked. They have asked us to show that it is 5 times PQ. So we must cross multiply. Therefore, SR is 5 PQ. Hence proved. This is how to do the sum, my friend. Very simple. Sum number 5. Okay, clear? We will go for sum number 6. In sum number 6 of our book, again we are with a trapezium. And we are having A, B, C, D and a O. In trapezium ABCD, AB is parallel to DC. So AB is parallel to DC. And the diagonals AC and BD intersect at O. Perfect. AB is 20. DC is 6. OB is 15. And we are supposed to find OD. How much is OD? This is what the sum says, 6 sum. Okay, so we'll start. In trapezium ABCD, first side AB is parallel to side DC given. Okay, therefore angle CDB is congruent to angle ABD. CDB is congruent to ABD. You can see, my friends, alternate angles. Okay, so we will write there alternate angles. Second, going further, okay, angle CDO is congruent to angle ABO. CDO is congruent to angle ABO. Why, my friends? Okay, because that is one. Because of betweenness, D lies between O and B, we can shorten. We can shorten because of betweenness. Third, in triangle COD and triangle AOB, in triangle COD and triangle AOB. Okay, we are here. First, angle CDO is congruent to angle ABO from 1. We have proved here. Okay, 1. Number 2, angle COD is congruent to angle AOB, vertically opposite angles. And third, we do require. Therefore, triangle COD is similar triangle AOB by AA test of similarity of triangles. So we have proved that the triangles are similar. Part B, they have told us that they are in ratio. So first we'll get the ratio. Fifth, therefore, we'll have DC upon BA is equal to OD upon OB. Corresponding sides of similar triangles are in proportion. Put the values. Therefore, 6 upon 20 is equal to OD upon 15. OD we have to find, which is X. We can put X here at this stage. Therefore, X is equal to 6 into 15 divided by 20. And this will give me 4.5 units. Okay, please write the answer. OD is equal to 4.5 units. This is how to do sum number 6. Please watch it 2-3 times. Pause. Copy in your notebook the proofs, the steps I show you, the triangles how I break up, which will be very useful to you when doing your final revision. Sum number 7. Again, we are given a parallelogram this time. A, B, C, D. And this is extended and D comes down, extended, cuts at point E. ABCD is a parallelogram, so opposite sides are parallel and congruent. Point E is on the side BC, B dash E dash C, betweenness. Line DE intersects ray AB, okay, in point T. They are meeting at point T. Prove that. We have to prove that. DE times BE is CE times DE. Okay, DE times BE is equal to CE times DE. Okay, so we are going for the twist. This is what we have to prove. Let's start. First, ABCD is a parallelogram given. Second, therefore, AB is parallel to CD. Opposite sides of a parallelogram are parallel. Then, segment, we will have BC is the transversal. So I have AD, I have BC, you can see, and I have the parallel sides. Actually, we are having AB is parallel to CD. Technically, we can remove the AD at present. So this is how it is appearing. Okay. Now, therefore, angle CBT is congruent to angle BCD, alternate angle. Same proof like last time. Angle CBT is equal to angle BCD. Okay, so simple. Alternate angles. Of course, this is a diagram, but we are not drawing further. We only need alternate angles. Okay, and angle TBE is congruent to angle DCE. TBE. Now we are cutting here. Okay, is congruent DCE. Betweenness, we have made the angle smaller. Okay, I will write here betweenness BEC. So if full angles are congruent, then the part of those angles are also congruent. Now, in triangle TBE and triangle DCE. Okay, first, angle TBE is congruent to angle DCE. We should mark this as 1, so I can write F from 1. If I leave a mark, otherwise I'll have to write again. Okay. Angle BET is congruent to angle CED, vertically opposite angles. Angle BET is congruent to CED. X. Therefore, triangle TBE is similar to triangle DCE by AA test of similarity of triangles. When triangles are similar, sides are in proportion. Therefore, BE upon CE is equal to TE upon DE. Corresponding sides of similar triangles are in proportion. Cross multiply, because we need it in that form. Therefore, DE into BE is equal to CE into TE. We have kept the order how they require. Hence, this is how to do the sum, my friends. Sum number 7 of exercise 1.3 in the textbook. Okay, and I've drawn individual diagrams. As I remind you again and again, you may draw, you may not draw, but if you draw and pencil that side, it makes life easier. And you will also remember how to go ahead in the sum. So this was sum number 7. Let us see the next. Sum number 8. Now we are having a figure like this. I'm having A, B, C, D and a P. In the figure, the AC and BD intersect each other at point P, and AP upon CP is equal to BP upon DP given. Okay? Or, so this is given. I have to prove that. What do I have to prove? I have to prove triangle ABP is similar to triangle CDP. ABP is similar to triangle. So, okay, this triangle 1 is similar to triangle 2. I have to prove this. Let's see, my friend. Very simple. Already they have given the answer on the board. Okay, in the given. So we have to just learn to write. In triangle ABP, take those triangles which they have asked, CDP. They have given us AP upon CP is BP upon DP given. Okay, and angle APB is congruent to angle CPD. Why? Vertically opposite angles. Angles in an X are, you can see, congruent. Vertically opposite angles. Therefore, triangle ABP is similar to triangle CDP. What do we write? Which test? SAS, test of similarity of triangle. Side angle side. Side angle side. Angle in between. Okay? So you have used this side, 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 and you use the angle in between. SAS, test. Okay, so simple sum. How to do? One step. For 1 marks, you should be ready. We'll go for sum number 9, which is the last sum, and our exercise will get completed. Sum number 9 of the textbook. In the figure is given. Okay, I'm having a figure like this: A, B, C, and a D. And in triangle ABC, point D is on side BC such that angle BAC is equal to angle ADC. Okay, so sorry, one piece. Okay, so this is given, and we have to prove CA square is equal to. So first, given in this, angle BAC is equal to angle ADC. To prove that CA square is equal to CB into CD. My friends, no, where we will get square from? Use common sense for your understanding. Don't write in the exam. CA square is CA into CA, is CB into CD. Okay, and when you see like this, you can get the sides. So I will have here CA upon CD is equal to CB upon CA. This is where. So if I have here, I can go here, I can go here. This should already come in my brains. Otherwise, you would not have any theorem for CA square. So let us start. Keep this in mind. Learn to interpret so you know how to go about it. In triangle ABC and triangle ADC or DAC. Going in order. Okay, first, angle BAC is congruent to angle ADC given. They have given us already. If measures are equal, angles are congruent. Second, angle BCA is congruent to angle ACD, common angle. C is common to both, common angle. Therefore, triangle ABC is similar to triangle DAC by AA test of similarity of triangles. Okay, if triangles are similar, sides in proportion, therefore CB upon CA is equal to CA upon CD, corresponding sides of similar triangle. Therefore, we will have CB into CD is equal to CA into CA, or CA square is equal to CB into CD. Hence proof. See how simple the theorem proof was. So nothing great. They had already given us most of the things, what to take, how to take. Although diagrams looks which side, which triangles, you don't have to bother anything. This is where we finished the exercise, and we will go for the next exercise in our next lecture. So we will stop here. So thank you.